Okay, in 2 days from now, you have an algebraic manipulation test. Basically, it's just using trig to solve problems. They just have words in them. Some people would make them scary sounding and call them word problems. So yes, you have some word problems. But all the word problems boil down to is almost always it's a right triangle, and then you just have to do trig on it. So for example, let's say that this is a ramp that somebody is building in their backyard because they want to launch their little, I don't know, electric car over their pool in the backyard. So they build this ramp, and it's got a 45-degree angle right there. Okay, and if they may really make this a right triangle, of course, that'd be a right angle. And this would have to be 45 also. And then they might tell you, and the piece of plywood that he had was 4 feet long. That's a typical 4x8 sheet of plywood. Okay, so that makes this 4 feet. That's the piece of plywood. Okay, this thing that he stacked it on needs to be how high? So they say that all in words, but by the time I draw this into just a triangle, you'll hopefully notice, oh, that's just trig. So you can do trig anytime you have an angle and a side, even just one angle in a right triangle, and then a side. Just one side is all you'd need. And that's what we have. We have an angle, which told us the other angle automatically, and a side. So how do I find x? You need to get used to this idea. Sine of some angle is 1/2, or sine of the angle, 45, is equal to the sides. You've got to, well, it wouldn't be, it'd be sine is opposite over, it would be 1 over square root of 2 in that case. You've got one of these pieces of info. They'll either give you the angle or they'll give you the sides. Whichever one they give you, you put in, and whichever one they don't give you, you put a variable for. So, on this problem, should I do sine, cosine, or tangent of the 45-degree angle? Sine. Sine of 45 is equal to, now I don't know right off the top of my head, but I know sine is opposite over hypotenuse, right? So I put a fraction and I put an O and an H. Do I know the opposite side? It's x. So I'm erasing the O and I'm putting in an x. Do I know the hypotenuse side? Yes, it's a 4. The hypotenuse is a 4. Do you get now? I have an equation and I just have to solve it for x. How do I get x alone? Multiply by times by 4, times by 4. Now, there are no calculators allowed. If there's no calculators allowed, how are you supposed to do this? Well, sine of 45? You know that. Yes? Yep, absolutely. Use 1 square root of 2. So then, sine is opposite over hypotenuse. From this angle's forward perspective, we could have used either angle, but opposite hypotenuse 1 over square root of 2. So where should I put that? Right here. Sine of 45 is 1 over square root of 2. So it's 4 times 1 over square root of 2. And put this over 1 because fractions play nice with other fractions. It's important. If you have a fraction, make the other one into a fraction and they'll work nicely together. And the final answer is 4 over square root of 2. Now, if we wanted a decimal for it, we could get a decimal by using your calculator. But do you get that that would for sure be an estimate then? Because we'd have to stop square root of 2 because square root of 2 goes on forever. So I can't get an exact answer unless I leave it this way. Think about this for a second. Do you remember that being on your last test? Give answers, give exact answers. It was in your last test. Give an exact answer. And that was meant use radians if you're doing it in degrees. On these problems, to give an exact answer, you would need to leave it this way. Do you get if you change this to like 1.6, unless you're willing to type decimals for the rest of your life, you're not going to have it exact. You'll have to round it. Because square root of 2 isn't just like 1.6. It goes on and on and on and on and on. So if you want an exact answer, you leave it like this. On the ACT test, most answers they give have like pi's in them or square roots of 2 in them. they almost never give you a decimal and say round it. Okay, they give you the exact answer like this. So this would be a perfectly good exact answer. Now, for those that might be watching this who are in a class where they require you to rationalize the denominator, then you'll have to multiply by root 2 over root 2, and that will make 4 root 2 over root 2 times root 2 makes root 4, which is 2. That also is exact. It's just written differently so it doesn't have a square root on the bottom. We do not require that in this class. You don't have to rationalize the denominator. You could have said 4 over root 2. All right, I'm going to give you another question that's similar. Yes, question? Okay, let me look here. Yes, this can simplify even further. You are correct. So the 4 and the 2 goes into both of them. 2 times 2 goes into 1. So there we go. 2 root 2. You are correct. We do want you to simplify them all the way. But again, we wouldn't have gone here in the first place because in this class we don't require you to rationalize denominators. So it would have been all right to leave it like that. All right, moving on. Here's another story problem, and I want you to use Trig to solve it. The fireman comes up to a house. I just heard about this in our in northern Wisconsin. There's a little town, and these people sold their house, and they just heard this scary news. Like a month after they sold their house to somebody, their house burned to the ground. It was like, holy cow! They sold it, and like just a month into owning it, the new person, they don't know exactly what happened. I don't know exactly what happened, but all I know is the place burned down. So, fire department fought it for 3 hours. One of the things that they try to do is sometimes to get into the house, they put a ladder up on the side of the house. Because if they want to get in it because they think there's somebody in there to like try to save them, of course, they're going to go to pretty great lengths to try to get in. So let's say that there is a 2-story house, and right away you should start drawing a picture, because that's the key to word problems, is having a good picture. All right, so there's a 2-story house. There's a window that they have to be able to get the ladder up to. They got to get to the bottom of that window. Okay, the firemen have a 45-foot ladder. And when they set it up against the house, it turns out that it is long enough, and that the angle that it'll make with the ground, as the fireman was kind of looking at it from the side, it looked to be about a 60-degree angle that it made with the ground. My question is, how high was that window? I'll say it again. The ladder was 45 feet long, and it looked like it was making a 60-degree angle with the ground. How high was that window? All right, picture's worth 1,000 words. Here's my ladder. And here's the angle with the ground. And it was 60. So that makes this 45 feet. And then this is the thing we wanted to know, right? Did you set up trig for it? It's either sine, cosine, or tangent of 60. What do you think? Should we use sine, cosine, or tangent? It's not like an automatic. We are not going to tell you what to use. You have to figure it out. So what do you think? Sine, because that has opposite and hypotenuse in it. And those are the things we have. If we use tangent, for instance, that has the x in it, but it doesn't have a number down here. So that's not going to work. You got to go with what you've been given. I've been given opposite and hypotenuse, so I use sine of 60 is equal to opposite x over hypotenuse 45. And then if I only knew what sine of 60 is, but you do, because you know that 30, 60, 90 triangle. So you make a new triangle over here that's a 30, 60, 90. You've done this a million times. And this is 1, 2, square root of 3. And then you ask yourself, what is the sine of 60? And you can find it right there. No calculator. So sine of 60, sine is opposite over hypotenuse. That over that. Root 3 over 2 equals x over 45. Now there's two schools of thought on this. Some people say, well, cross multiply and solve. That's true, but there's a faster way. We just want x alone. What do? Multiply by 45. And now x is low. So then, if we were allowed to use a calculator, you would have probably used it right here and got a decimal, but we could use it at this point and figure out what the square root of 3 is, times it by 45, and then divide it by 2. Or we can leave it as 45 root 3 over 2, and that's, why is that better in a way than using the calculator? Because it's exact. It's exact, meaning the square root of 3 hasn't been compromised by being rounded. All right. There's another formula you'll have to know besides just your basic trig. S equals theta r. I like to sometimes call it the Soar formula. S, and this is like it's an O, but it's not really an O, it's a theta. And do you remember how this goes for arcs, arc length? So if you have a circle, and you have one wedge of that circle, oh, that's a pretty big wedge. Hold on a second here. And let's say this part right here is 2 miles long. And this part right here is the radius of the circle. Let's say that I don't know that. And let's say that I know the angle. And the angle is pi over 4. In other words, a 45-degree angle. They could ask you, how big was the radius of this circle? It might be a search radius. Every now and then, they've been losing planes lately. You know, they lost that one that was flying over the, what was it, the Indian Ocean? Where they, do you know what I'm talking about? Like a year or a year and a half ago, a plane just disappeared. Yeah, the Malaysian airliner. Was it over the, where, what ocean was it over? I can't remember. I'm guessing it was near Malaysia. I think it was the Indian Ocean. Okay, anyway, they have search radiuses that are just ridiculous and things like that. Like, there was so many square miles they had to search, it was just almost impossible. And I think they just released info that one of the 2 pinger boxes, they actually have proof that it was not working anymore, like the battery had died in it. With just an oops, they forgot to replace the battery in the thing. So there was only 1 pinger left on this plane. And then, I don't know if you remember, but they found some just at the last minute, right before the ping battery was going to wear out. They got a few last pings, and then it stopped because the battery ran out, because that's what's supposed to happen over like a month. But they didn't find it for like a month, and so they still don't know where that thing is. They haven't ever found the wreckage. So anyway, the reason I say that is you're going to be in the context of a search radius, and let's say that they said they've searched this sector right here, and you know that the boat went 2 miles from the center of the circle in its arc, and then they could say what was the radius of the search area. Okay, so hopefully you're setting this up as S equals theta r, and S is your arc. That's a terrible letter for it. It really should be an A, but S is the arc length. And this is the radians, and this is the radius. Don't get sucked into thinking you can put degrees right here. Yeah, that is 45 degrees, but you can't use that. You have to use the radians, pi over 4. And arc we knew, 2 miles. 2 equals pi over 4 times r. And then all you have to do is get the r alone. 1 step is the best. You could multiply by 4 over pi. But second best, use that rule we've always said, clear your fractions. It's times by 4 on both sides. And then divide by pi. It's going to have the same effect. Final answer, 8 over pi. What's good about leaving the pi in there? It's exact. As opposed to if you took a calculator and did it with a calculator and said 8 divided by 3.141592653, blah, 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 you'd get a nice decimal answer, but it wouldn't be exact anymore because you had to round pi. All right. So there is a second kind of word problem. Let's actually just start in on your homework. Everybody find, that's not it, 4.8.1. I'll pause for a second while I find that. Okay, 4.8.1. For each problem, provide an appropriate sketch. Ooh, so not only is it handy to have a good picture, It's required in the directions. Set up an equation, which is usually going to involve trig, and then give each answer to the nearest, let me see what it says, hundredth. Okay. A guy wire. I know you may not know what a guy wire is, but that's the kind of wire that goes to the very top of those towers and then comes all the way down to the ground. That's a guy wire. Okay. From the top of a transmission tower at WJBC forms a 75-degree angle with the ground. Okay, so that's saying, here's the ground, here's the wire, here is 75. At a 55-foot distance from the base of the tower. You can't like come up during the test and say, where is the 55? You have to be able to interpret it from the directions. And it says from the base of the tower. So then either they just told me this was 55, or they just told me that the ground distance was 55. I hope you can tell the difference. And it says, at a 55-foot distance from the base of the tower, and they were just talking about the wire. So the wire to the base of the tower, they were telling you the bottom was 55. Besides, the question was, how tall is the tower? And it's not likely they just give it to you in the problem, right? Okay, so then the question is, how big is that? Do you get how I can use trig on this? Now, I did say that you were going to be using without calculators. I think I'm wrong now, because right away the very first problem here asks for a problem you'd have to do 75 degrees in. So either we'd have to leave like sine of 75 degrees in our answer, or or maybe tangent, I think, in this case. Or we'd have to use a calculator. I'm going to double check that right now. All right, I've determined I was wrong. Calcs are going to be allowed in this next test. If they're not, I'll tell you tomorrow for sure, but the test does not say no calculator, and they look like tough numbers. So that means calcs will be allowed. You still have to set up an equation, though. So this is either sine, cosine, or tangent of 75. Do you get that the two things we were given are the opposite and the adjacent? So hopefully you're using tangent of 75 equals opposite over adjacent. And now the x is almost alone. I just got to times by 55. If I wanted an exact answer, that would be it. 55 times tangent of 75. But on these, we were just going to type into the calculator tangent of 75. One thing though, everybody type in tangent of 75, and I bet you there'll be 5 of you will get a different answer. Tangent 75, enter. Just tell me what tangent of 75 is. Use your calculator. Raise your hand if you've got an answer. I just need a couple people. Yes? 3.732. All right. Who has that same answer as he did? Okay. Who has a different answer completely? All right. See what I was talking about? Okay. What was your answer? Negative point what? 420. Who had that answer? All right. Can anybody guess why two people typing the exact same thing into the calculator are getting completely different answers? Yes, sir. Some people are in radians. Some people are in degrees. Do you get 75 was in degrees? Everybody check quick under mode. What are you in? Hit mode. Are you in degrees or radians? I'm guessing most people were in degrees, but I don't know. How many of you were in degrees? Okay. How many of you were in radians? The people that got that negative answer, you were in radians. So, moral of the story, I hope you didn't take your ACT test like that, because that means you did all your trig problems wrong, because at least of anything you used the calculator for. So, that's coming soon, right? What do you want to be in when you take your ACT test? Degrees. Everybody get in degree mode. Unless you're going to be typing in your answers in radians. But that's really unusual. I bet nobody in here took 75, converted it to radians, and then used radians. Okay, so 3.732 was apparently the right answer. I times by 55, and then I will have to round it off, and it does say to the nearest hundredth. In case you've forgotten place values, That's the tenths, that's the hundredths. You don't round until you're the very end, but at the very end we want 2 decimal places. What did you get, Mr. M? 100 and something. Is it? Did anybody else get 200 and something? Okay, 205 point what? 0.26. Is that rounded correctly? Did you get 26 also? Okay, good. All right, good. And then this one, we gotta have correct units on. Otherwise, you will lose the points. Because that's not chickens, it's not degrees, it's not inches. What is it? Feet. If you don't have the right units, you're going to lose at minimum 5% on these problems. Okay, so make sure that you look through and figure out what was I trying to find here? Length of a wire, oh yeah, it was measured in feet. I'll do feet. Okay, now another kind of problem setup that is definitely a little more challenging is this next kind that's got the house with the deck. It's just 2 triangles, but yet it always is confusing for people. The angle of elevation, okay, angle of elevation means, elevate means to lift up. So like, just to make sure you get this, do you get the angle of elevation is an angle that's going up from that guy's perspective. It's like he's tilting his head back and he's looking up. That's as opposed to when they talk about an angle of depression, means you're standing somewhere, here's my stick figure guy, and he's looking this way, and then when he looks down, that'll be an angle of depression. An angle of elevation means he's looking up. So now this one's got a picture for you, so it wouldn't have been so bad, but a lot of people do it wrong. They're like, you know, the guy's standing on a building, so they're assuming the guy's going to look down, and so they draw the triangle looking down, but it's an angle of elevation. Could you be on top of a building and still looking up at something? Yes, you could. So if they say angle of elevation, make sure you draw your straight line first, and then you go up from there. So your triangle, if he's looking up at a plane or something in the sky, then you draw your triangle like that. If the guy's looking down at the ground, that's called an angle of depression, and you draw your straight line, and then you say he's looking down here at an angle of like 80 degrees. That means he's looking down at the ground. Okay, depression goes down, sort of like your head. If you're depressed, you're probably looking down. And if you're like elevated, you know, kind of up, you're looking up, your head's up, and looking up in the skies. All right, so I needed to get that across to you because so often people get these wrong just because they didn't do elevation and depression right. Depression, draw a straight line straight across and go down. Elevation from an observer to the bottom edge of the Delaware River drawbridge observation deck, located 200 feet from the observer, ooh, good, it says the 200 labeled here, is 30 degrees. Okay, so then how come we have another one? The angle of elevation from the observer to the top of the observation deck is 40 degrees. What they're saying is, if he tests to tilt his head and look up at a sharper angle to the top. Now, can you actually believe that somebody would be able to look up and measure the angle that they're at? Especially with today's iPhones, you absolutely can, or your iPad. I'm going to pause for just a minute and show you how you can tell what angle you are looking at. Okay? I'll show you that app. Okay, we had fun looking at our bubble level thing. And now, we'll probably use that tomorrow out in the comments. So let's finish this problem. Do you get that there are actually 2 triangles here? There's a triangle. I'm going to make a green triangle right here. That's one triangle. And then there's this blue triangle here that goes at a 40-degree angle. Also goes with 200 feet. Those are 2 completely separate triangles. What they want is the height of the observation deck, which is this distance between here and here. Do you get you're going to have to find the blue height over here, and then the green height, and then subtract them? Does that make sense? So you're going to have to do this blue one, which is 30 here, and 200 here, and x here. And then I'll draw this other one in green. No, wait, it's not 30, it's 40 degrees. Sorry. The big one is 40. And then the green one is 30-degree angle and 200 feet here, and I'm going to call it y. And I'm going to have to take the bigger one minus the smaller one. So you figure out this, and you figure out this, and then you subtract them. So you need to do two trig problems. So what do I have here? I have, from this 40-degree angles perspective, opposite and adjacent, so tangent. Tangent of 40 is equal to x over 200, and you solve that. And then this green one, you'll have tangent of 30 equals y over 200, and you'll solve that. And then you'll have two answers. One's x and one's y. And one will be the bigger height, one will be the smaller one, and then you just have to subtract them. So that's about as tricky as they get, and it's just two triangles that are nested together. All right. The hard part on these problems is really not the trig, honestly. The hard part is just figuring out what the triangles are and labeling your triangles well. All right. This one's I kind of like, number 5. It's about a lake. And do you get, if you are going to, measure across a lake and figure out how far that is, it's going to be difficult to, go across a lake and spread a tape measure out or whatever. Nowadays, it's possible you could use GPS to figure out your distance across something like this, but you'd have to stand here and you'd have to stand there and get your GPS readings and figure them out. But so to do this, they just walk 100 feet and then they recite down here and they figure out the angle difference. So if you walk 100 feet here and then you figure out the angle difference right there, which is 75.2 degrees, do you get, I have one side and I have one angle, and now I can figure out how far it is across the lake, even though I never went across the lake? It's kind of cool. I only walked 100 feet this way. All right. So they actually discuss having another person standing over here, but I'm not sure you'd even have to have that. All right, so bottom line is I have a side. I can figure out either how far across the lake or how far from A to B. It asks you for AC. That means x is how far is the thing you want. And from there, it should be easy. Sine, cosine, or tangent of 75.2 equals, and then depending what you pick, I'd probably pick tangent again. You'll use tangent a lot because it's got the two sides of the right triangle. It's got like opposite and adjacent. Okay, so there's a hint on how to do number 5. And I want to give you time to work in class today. These are not super easy questions, but I tell you, if you aren't trying to draw the picture, don't even bother coming up and ask me a question about the problem until you've tried to draw the picture. Okay, because you're just standing there looking at a bunch of words, I'd be confused too. As soon as you realize that it's a triangle almost every time, and then you start filling in the sides and the angles in the triangle, it's really not that bad. Okay, so get the picture drawn, and if you're stuck, and at least I can see you started a picture, I'll help you. But I'm not just going to do all these problems for you. You've got to struggle through them. These are not super easy. We need you to really do your absolute best work on these. Any last questions? Yeah, you don't have to do them all tonight. Fair question. Yes. There are lots of problems here, and these are all the ones we're assigning between today and tomorrow, and then the test is the next day. Okay, so this is 2 days worth of assignments. So why don't I tell you how far I would want you to get? I would say, how many total, does it have a total number of problems? 34. 34? All right. And I'm not going to need you to do all of them to practice, but I think it's out of 34, if we do about 15 each day is about 30, so why don't we aim for like 15? So on this day, since I had to do a lot more explaining, we'll do even less. Why don't I have you go to problem 10 today, 1 through 10. 10 questions. I would bet you that 9 out of the 10 are just right triangles. Okay? That's all I have for you for today. We'll do some more of these actual problems with you tomorrow. And this is where, I told you before, Trig's getting tougher. This isn't an incredibly hard trig. It's hard because of the words, but This next test is an algebraic manipulation test. They are the toughest tests that you have in Precalc. The category algebraic manipulation. They are the most retaken tests by far. So this test is not going to be an easy one. So make sure you spend the quality time today and tomorrow to give yourself the best chance possible on this test. Again, this is still the relatively easy trig part. Take advantage of that.